Hello all, today we are discuss about remote object activation and how does remote object activation work. First, what is meant by remote object activation? The RMI, that is Java Remote Method Invocation System, in a mechanism that enables an object on one Java virtual machine to invoke method on an object in another Java virtual machine. Any object whose method can be invoked in this way must implement the Java. The ability of automatically create the remote object triggered by a request for the references to this object. Support for the activation groups in which the groups of active table remote object are executed in the same Java VM, which is automatically started by an activation service if needed. The problem of running a large number of ideal RMI services can be solved with a remote object activation. It permits the services to be registered but not instantiated with the RMI registry. Then, how does remote object activation work? Remote object activation differs from a standard RMI servers in a few ways. A service must be accessible through an RMI registry in order to be found, but this usually necessitates the creation of an object. Faulting a remote reference is registered in its place because the goal is to avoid instantiating RMI server and instead activate them as needed. A faulting remote interface is one that operates as a proxy between the remote client and the server that has not yet been activated. A server installation program runs for a limited time, unlike Unicore's remote object server, which continues permanently. Its goal is to alert the activation system about an active table remote item, as well as to register the faulting remote reference with the RMI registry. This figure represents server installation program register active table object with RMID and faulting reference with RMI registry. When the registration complete, the server installation program can terminate, and creating the remote object is now the responsibility of the faulting the reference and the remote method activation system daemon. An RMI client will look up the RMI registry at some point in the future and select the service supplied by a faulting the remote object, remote reference. When the faulting reference is turned on, it checks to see if it already has a server reference. The faulting reference will be null the first time it receives a call, indicating that a server must be activated before it can be utilized. It uses the RMID program to establish a new server instance, and then it forwards the call to the newly active object. Requests for methods to the faulting reference are sent to the activated object, which is subsequently returned to the client. Although there is a little delay on a wakes up, this does not occur for a future request because the service is ready to use. The elegance of this method lies in the fact that the client is fully oblivious of the server implementation specified at all times. Although there may be a minor delay when generating the remote object at first, future calls are faster and the client has no way of knowing whether the server has always been active or was activated lately. This eliminates the need to compile additional code and eliminates additional work for client developers. This figure represented faulting reference with the aid of activation system passes information from activated object back to client. Then how we can creating an active table remote object. Although the creation of an active table remote object is different slightly from that of the unicast remote object, the coding is very similar. Let's start with a basic remote interface and see how it would be implemented as a remote object that can be activated. public interface my remote interface extend java.rmi remote public void do something throws java.rmi remote exception. The RMI service interface and has only one method, do something, which accepts no parameters and throws a remote exception if it fails. A typical remote interface and one that will be implemented by an active table remote object are identical. In fact, both an active table object and a unicast remote object can implement an interface. The next step is to add an extension to the java.rmi.activation class. Then next is activable class. It must implement our RMI interface and have a constructor as well as do something method. A different constructor signature is utilized than in classes that extend the unicast remote object class. This constructor invokes the parent constructor and export the object to any port that is available. Client can then take advantage of the service. Advantages: car insurance comparison table checks for the project constructor. Let us consider the program. Public class my remote interface impl extend java.rmi activation.activatable implements my remote interface public my remote interface impl java.rmi activation id java.rmi marshal object data throws java.rmi remote exception. Call the active table activation id int port parent constructor super activation id, 0. Public void do something system.out.println doing something. Then next topic is the roles of client and server. In an RMI application, we write two programs, a server program that reside on the server and a client program that reside on a client. Inside a server program, a remote object is created and reference of that object is made available for the client using the registry. A client is a program that makes use of services provided by the other programs. Server are the program that supply the services. Separating a client is a program that makes the service provided by the other program, and the servers are the program that supply the services. A client requests a service and a server fulfills that request. A resource management in which a server synchronizes and maintains access to a resource and responds to client requests with data on status information is a common requirement for server function. User interaction are often handled by a client program, which frequently requests data or initiate data modification on the user's behalf. A client, for example, can supply a form on which a user, for example, a person working at a data entry terminal, can submit product order. This order information is then sent from the client to server, which validate the product database and execute a necessary billing and shipping operations. A single server is usually used by the several clients. For example, a few servers that govern database access can interact with dozens or hundreds of clients. A client is not required to know anything about the resource manager in question. If you change the database you are using, the server may need to be updated, but the client does not need to be updated. The update procedure is additionally simplified since there are normally fewer copies of the server than there are of the client, and because of the server are often in location that are easier to update, for example on central workstation rather than on PCs on user desks. This method also adds a layer of security. The data that the resource manager manages is only accessible to the server, not the clients. Client can connect to several servers while server can also connect to the other server as a client. It is up to the application designer to decide how the functions are divided between servers. A single server, for example, may supply all of the client services, or the client could access many servers to execute a separate request. Scalability, location, security are all the factors that must be considered by the application creator. Is the program deployed throughout a large geographic area, for example, or are the clients or servers local? Is it necessary for the server to run on a physically secure machine? The scope of this introduction does not include such design judgments. Application servers are servers that are used as a part of an application. Other servers are not associated with a single application. Instead, they can be used by any application. The CICS structure file server, that is SFS, for example, gives programs record-oriented file access. Then our next topic is simple client or server application using RMI. The RMI application is made up of two programmers, a server and a client. A typical server software generates some distant object, make the references to them available, and then wait for a client to call a method on them. The RMI program is responsible for allowing the server and the client to communicate and transmit the information back and forth. The RMI registry is used by the RMI distributed application to gain a reference to a remote item. To associate a name with a remote object, the server contacts the registry. The client searches the server registry for the remote object by name and then call a method on it. Then next is receive message interface.java. Let us consider the program which defines the RMI interface and receive message method is implemented in the server class. That is import java.rmi public interface receive message interface extend remote void receiver receive message string x throws remote exception. You will learn how to send a message from RMI client to RMI server in this part. We will make the receiver message interface here. The method that can be called from the client are defined by the interface. In essence, the interface determines how the client sees the remote item. Following that, we will develop a class called RMI server. The RMI server accepts client tasks, execute them, and deliver any result. A server code consists of the interface and a class. The receiver message method which is invoked from the remote client and is defined in this class. This class is implementation of the RMI interface. The registry is created by the RMI server. This is a directory of sort. It has a name as its key, which is the ID of a remote object, and an object as its content. The name of this object is searched from a remote application. The TP address or the host name as well as the port number are used to access this register from the remote device. Create a registry. The function create and export a register on the local host that accept the request on the specified port. This is the explanation of this receiver message interface.java program. Then now code for the RMI server. This is the code, means program is used for the RMI server. The output of this program is java rmi server.java java rmi server. The address is equal to code india /192.168.10.108 port 5000 t is equal to _5000. This is the output for the RMI server. Then the code for the RMI client is in this way. We have already discussed in detail. The output of this program is Java RMI client 192.168.10.104.1043232 rows India, sending rows India to 192.168.10.102 104 as to 3232. If the RMI client sends any type of message, then the message will be displayed on RMI server. Java RMI server is equal to this address equal to rows int d 192.168.10.104 port 3232 rows India. This is the output for the program of or the code for RMI client. Thank you guys.